Ladies and gentlemen, it's a distinct honor to welcome a speaker who stands at the global forefront of the theoretical foundation of artificial intelligence, Professor Michal Baczynski. Michal was born in Katowice and graduated at the University of Silesia in Katowice, where he currently serves as a deputy dean of the doctoral school of the university. If we were able to define his scientific contribution with a single word, it would be undoubtedly the implication. His landmark monograph, Fuzzy Implications, which was published by Springer and co-author with Balu Jayaram, has become the definitive Bible for researchers worldwide in this field. With over 150 scientific publications to his name, Michal's influence extends far beyond his own research. He is a prominent figure in the international scientific community, serving on the board of Polish Fuzzy Set Society as a key member of program committees for major global conferences such as EUSFLAT or IFSA. His dedication to excellence has earned him numerous awards from the rector of the University of Silesia, as well as prestigious state honors for his contributions to Polish science. Despite spending his days in the rigorous world of mathematical proofs and functional equations, Michal maintains a sharp sense of wit. Regarding the uncertainty to which he has dedicated his career, he often quips, "The beauty of math is that we seek absolute truth, but thanks to fuzzy logic, we know that even absolute truth can sometimes have a membership degree of only 0.9. So, ladies and gentlemen, please join me in welcoming a man who brings logic to the complex and clarity to the fuzzy, Professor Michal Baczynski.
Thank you. It's a great honor to be here, and I would like to thank you, the organizers, for the invitation, and thank you for these words. I would like to say today, after these 5 days of the many talks, presentations, something about fuzzy logic connectivity. But firstly, I have some history. It doesn't work. Now it's working. Okay. Some history. My first conference here during FSTA was 26 years ago, 2000. I see some persons who have been also at that time, but most of you not. I have found the program of this conference on my email, and that was the first day, Monday. Similar talks like today. If you look for the first talk, also from the Italy, Daniele Mondici, also about the probability of MV algebras. Similarly, like today, we have heard about the MV algebras. And we had also the 2 talks connected directly with the triangular norms. Siegfried Goldwald, who has passed away several years ago, and also Radko Merciar about triangular norms and generators. I remember that Martina was also in 2000, and also Ivana, and I met many persons first time during that conference, because it was my second conference, in fact, connected with the fuzzy logic. Now speaking the second conference. Of course, that was the year when the book of Clement Merciar Pap was published, 2000. So this is the reason why almost all the presentations were connected with the triangular norms, triangular conors, and different kind of the characterizations and so on. But I also remember one talk, maybe you remember the closet norm t-shirts. You remember this one? I remember that the organizers, they have the t-shirt, the closet norm on the back. The closet norm was published in this Clement Merciar Pap as a contra-example for some presentation. So this is the reason why I have decided that the first part of my presentation will be connected with the triangular norms. So it will be not my results. I would like just to look what's going on this topic in last years. So the first part will be about the theory of some T-norms, T-conorms, and so on. But just a short overview, what are the main contributions from the point of view of the algebraic, of the characterizations of the functional equations and also functional analysis. So first topic, which is really very many persons are working on this one, is the theory of the T-norms on the boundary lattices. Michał Holczapek is here. No, he traveled probably. No, somewhere. Okay. But Michał is also working on this topic. Emel Ashici from the Turkey, Peter Wycienik. And also we have not only in the phases in the system, but as you can see in Cybernetica and also in Equations Mathematica, almost all the articles starts with the new constructions, new constructions, new constructions. Yeah, so you can see that we have a huge family of the new families of the T-norms, triangular norms, but mainly on the boundary lattices. And I just only wanted to stress maybe one result to show you in which direction it goes. Probably all of you know the very famous theorem about the characterizations of the continuous Archimedean T-norms. And for example, in this article, we have obtained the similar theorem in the case of the bounded lattices. So we have also some generator. We have also such a representation. Of course, the generator is from the lattice to the zero infinity, so similarly like in the classical case. So such a theorem can be obtained. Here we have not even only if we have only one representation. And of course, we can prove that if the theorem is about lattices has a generative additive, then T is Archimedean. And we don't have any uniqueness. And of course, when the bounded lattice is finite, such a generator can be constructed explicitly, and such a construction can be found in such articles. Last one, Mirko Navarra also traveled, but because I had discussed with him yesterday that he will not be here, but he also worked on this topic. He presented some article about the discrete Archimedean T-norms. So again, the problem on the discrete case. So not the continuous one, not on the 0-1 interval. So the question is about the maximal discrete Archimedean T-norms. And here this publication is connected with the Fibonacci graph contains in the generator sequences. But we still probably have this open question. So we don't describe all Archimedean T-norms and their numbers, but we have completed at least a significant step towards to this goal. And in my opinion, it is still an open question, but I am not the specialist here. But in my opinion, this is one of the topics which is still under the investigations. Okay, I'm working with Dybalo and Professor Radko Messer on the fuzzy implications, but they have also worked on the generation of the continuous norms for lattical operations. So this is again some example of what we have here. We know that we take the maximum and minimum pairwise of the two T-norms, even continuous T-norms. The result is not a continuous T-norm. So the question is what we can obtain here, and they have investigated how we can organize a new order. Without any details, they have just introduced some operations on the additive generators, and they introduced some operations. They find two binary operations which generate new continuous norms, and we have some ordering, and they construct the lattice. So in the classical case, we don't have a lattice, but in this construction, we have this lattice. Yeah, so Bernard also traveled, okay. And he also worked on the pseudo-inverse on the completed lattice. So as you can see, we have some complete lattice, and again, some characterization, some representation, not the same as in the case of the previous presentation, Archimedean norms, but quite similar one. Instead of we have here minimum, but we have here some not pseudo-inverse, but a new one, a different one. Also, Radko worked in this topic, just article from the previous one about the T-norms having additive generators. And finally, a huge topic and many number of articles. I have just only stressed the one. I'm just working with the Huyan Zhu about in some project about the fuzzy implication, but not the fuzzy implications. But he's working on the ordinal sum representations, and also here we have many articles and also many contributions connected with the ordinal sum constructions. So just short summary, what we have done, what I wanted to stress here, that during last years, we have still many articles connected with the triangular norms after the book of the Clement Mesher-Papp, and also the other books are connected with the associative functions by the Claudio Alsina and the other authors. We move more to the lattices. So we are working on the lattices. We are still looking for the additive generators and also on the algebraic structures and ordinal sums. So, but what was the next topic? New topics which are just started in 2025, 2026. It is connected with the Bernard talk. I remember, maybe you remember, so the psoset, yes, he had introduced psoset. I remember this word very well. Psoset, okay. So ordinal sums of triangular norms on bounded traits. This is some special case of the psoset. So you can see here that there is another way for looking of a new solutions, maybe on some particular, maybe not complete lattices by some other structures. This is still a new topic, and maybe we will have a new result here. Okay, as you know, I'm working on the fuzzy implication, so I would like to here not to put all the results because it is impossible. But I also would like to stress some new results, really, in my opinion, very interesting, which I'm working on this topic. So again, I would like to, because I'm at my university, functional equations are very popular, or are still very popular. We had a great mathematicians working on this topic. Unfortunately, Professor Ger, who was the boss of this committee, passed away a year ago. But we still have mathematicians who are working on this topic. Previously, from Professor Marek Kuczma, then Professor Ger. We have many also seminars connected with the functional equations. So functional equations are very close to my heart. And I would like to discuss today some of them. But first, some history. 2008. That was the plenary. This is a photo from my plenary talk during this conference. I had the plenary talk similar about the fuzzy implications, happily not in the last day. But you can see here Professor Szostak from Latvia. You can see here Professor Clement, and also many other persons here. So we had this. I had this talk, and it was my first plenary talk connected with this committee. So thank you very much that I am able to do it once again here. So that was also the year, similar situation like previously. So 2000 was the plenary talk about the triangular norms. Here was the plenary talk about the fuzzy implications, and as was mentioned at the beginning, it was the year when this book was published about with the Balu, with my friend from India, about the fuzzy implications. Then we have also published some other books. But what is important also, I would like to stress about the Sebastian Masena talk in Bratislava. Maybe you remember that he had a talk about the fuzzy implication functions 2.0, yes? About from theoretical results to applications and vice versa. So we have also some other presentations connected with the fuzzy implications, and not maybe on the FSTA, but also in a similar conference. So, speaking of how we are working, because I'm interested in functional equations, and here we have, speaking, two main ways of working. So we are looking for the logical property from the different point of view, maybe from the applications, maybe from the point of view of the reasoning schema. We are trying to translate this property to the functional equation under some constraints, probably monotonicity, boundary constraints. We start to obtain full characterizations or strong restrictions, maybe some counterexamples. And then, of course, discuss about possible applications and classify solutions and discuss between different families. Today we have heard about the Łukasiewicz implication, also about the cleanliness implication. Yesterday during the Ines talk, we have heard about the gathering implication also. So we have many different kind of applications, and of course, uh, we know that there are sometimes maybe even too many articles on this topic. This is the reason why we have published this article with the Sebastian and with Raquel and with Balu about the valuable and trouble practices, because we have seen that there are sometimes too many, how to say, not very deep, we can say, articles where we have just proposition of the new family, properties, that's all. But in my opinion, in our opinion, this is too less. We need to discuss a little more why we are discussing new families, why they are important, from which point of view, maybe some characterizations, and why they are connected with the other families, well-known families like residual implications or less implications and so on. So this is the topic. Okay, we know what is the definition of a fuzzy implication, and we have many different kinds of families. Generally speaking, the definition is very general. It is just a monotonic in the first variable, monotonic in the second variable, and satisfy the boundary conditions. And today I would like, just in this moment, I would like to discuss a little more about the preference implication, because in my opinion, this is really very interesting family. Maybe can be useful for you in your investigations, maybe can be useful in your solutions, I don't know. But I would just stress the why we are working on this topic and why they are quite interesting, and what are the main properties of this family. In my opinion, this article is really really one of my best articles, because really the proofs are quite interesting and hard. And so what we have done with Professor Dombi from Hungary. Professor Dombi also has been here doing FSTA many times. He also had some talks. Unfortunately, he is now retired. He's still working in Hungary, but maybe not travel so many. But we have discussed. Today we have heard about the cleanliness implication. Yes, the traditional one with the minimum not P or maximum not P or Q. This is the traditional implication. But we have just considered this family in the different aspects. So we consider here some not necessarily the Tico norm, but we take here the aggregative operator, in fact, uninorm, and we take here a particular negation. And main agenda is the following, that we want to classify implications via distributivity functional equations. I will discuss a little more in a moment. And the preference implication, it is one solution under some constraints this problem. So firstly, what we have just here, probably this can be also generalized to the lattice theory, and this is still an open problem. We have not started on this topic, but maybe this is another project for in the future. But in the classical case, we are just consider the generators of the continuous T-norm and continuous T-norm. In fact, continuous strict T-norm and strict T-norm. We assume that the multiplication of them is equal to 1. So in fact, one can be obtained by the second. We have a formula for the negation, and we have also the formula for the conjunction and disjunction. We can think about this value ni, as a threshold, because this is a fixed point of the negation. So depending of this fixed point, I can decide what is the threshold. This one can be also important for example, in the machine learning, because we have also the optimization functions where the threshold is also very important. So this is why we are thinking about the threshold, that we decide which point we can be chosen as a threshold. Okay, and then we have the formula for the conjunction. Then we have formula for the disjunction. We can also generate the standard not associative functions. Later, I will discuss this topic a little more, but I only want to stress that we can consider the similar families like for the classical T-norms and T-norms, but with some parameters. And in this case, we obtain such a family of the not associative operators. Dombey showed that this triplet is forms the Morgan system. So from the point of view of of our theory, it is quite interesting, quite good. And we have also the uninorm, and this uninorm, this is a representative uninorm, can be presented in the following form. So we have again some kind of the function often generated by the one function. What is quite important that it is in this formula we take either generator of a strict norm or strict norm, and we obtain exactly the same formula. So we can work either on T norms or T norms, doesn't matter. And of course, we can have the conjunctive uninorm or disjunctive uninorm. And in this article, we have just obtained it. We have presented such a formula, but the goal is not that okay, we have just put the well-known formula to this equation, obtain this formula, and this is nice. It is nice because it satisfies many interesting properties, and I would like to stress today, and I would like to show you which properties are the most important for us. So, first of all, some examples. Okay, if we take just the generator of a Dombey norm, we obtain the following preference implication. What was interesting, we have found this implication even in 2008, but at that time it was not interesting for us. It was just an example of some UN implication. And later we have found that it is also the preference implication. In my opinion, this proposition 3 is the most important example why it can be useful in the practice. We also, during the Bernard talk about the preferences. Here we don't have the preference structure, but we have the preference implication. So the implication is connected with such an inequalities. So if we have a threshold, then the value of the implication is greater than threshold if and only if x is less than y. It is equal to the threshold if and only if x is equal to y, and it is less than threshold if and only if x is greater than y. So in our opinion, this is quite nice properties. And we can think, we can think that y is preferred over x if and only if the value of the preference implication is greater to or than or equal to the value of the parameter y nu. So as you can see, the name of this family goes from this proposition. Okay, but this is not the only property, not the only properties which are interesting from my point of view, from our point of view, but it also satisfies, okay, exchange principle, satisfies contraposition laws, it satisfies also the conditionality. I will say a little more about the conditionality in a moment. So we have such an inequality. Okay, again, with some preferences. So only when x is greater than nu and y is greater than nu, then the preference implication satisfies this conditionality. Normally, it should satisfy for all x and y, but here in this case, we have a threshold. So we are thinking only about the x and y, which are greater than a threshold. And we have also the conjunctive operator. So in the case, we have the equality. But the old problem, and investigated also by many authors in many articles, is connected with the distributivity equations. So in classical logic, we have this formula, d1 up to d4, small d1 up to d4. Then we can translate these distributivity equations to the functional equations in the classical case for the unit interval. Of course, if we were working with on the lattices, or we are working on the interval evaluate sets, then we have the different assumptions, but we just concentrate here in the classical case. And now how we can solve this problem? So we can solve this problem from the 2 points of view. From the one point of view, we can assume that the function I is given. So we know, for example, the I is I don't know, is an S implication, R implication, or a given function, and we are looking for the other connectivities which satisfy these equations. Or from the other point of view, we can just assume that the connections, the conjunction or the junctions are well known. from the given family or for the particular formula, and we are looking for the fuzzy implication that satisfies these equations. Of course, in general, solving such an equation without any assumptions is almost impossible, yes, because there are too many solutions. What is important? It was shown that distributivity equations have a very important role to play in the approximate reasoning. So it was presented by some authors that, especially in fuzzy control systems, we can reduce the number of the axioms or number of the rules if the system satisfies the distributivity. And of course, the number of the rules directly affects the computational the computational efficiency in the control system. So from the one point of view, it can be just a theoretical question. So I'm a theoretician, so I'm looking for this point of view from the mathematical point of view. But I'm also not that this can be also interesting from the point of view of applications. And there were a huge discussion in the transactional fuzzy systems many years ago about that we need to find as many as possible solutions in the case of the distributivity. So what we have found, I'm just presenting the main result of this paper. We have obtained that under some assumptions, they are quite strict, okay? So we assume that the conjunction and disjunction are known. There are weighted operators. They should satisfy the De Morgan laws. The negation should be a strong negation, like on the FSTA new logo. We have also the negation here and on this logo. So what we obtain, that the system, in this case, of course, C and D are just given here, but the implication is just the preference implication. So in fact, our investigation on this topic was not the following, that we have found the formula. But firstly, we have started to investigate the distributivity. We found that this implication satisfied the distributivity, and then we have investigated the properties of this family. Okay, and this is really very, in my opinion, very nice also theorem, because this is the if and only if theorem, and quite interesting. But what next about the preference implications? I would like to show you some new results also about this preference implication. Michał is here, okay? Okay, and it's okay. Okay, so it can be also used in the multi-criteria decision making. We have such a preference relations properties, which were introduced many years ago by Tanino or by Bezdek in in the previous century. And the preference relation is multiplicative transitive, or it is reciprocal. And it can be shown that if a preference relation is multiplicative transitive and reciprocal, then it should satisfy the following formula, the following equation. And we have obtained that the only solution in this case for the preference implication is just for the Dombey operator and for the threshold equal half. And so it shows that, for example, this formula can be maybe important, can be useful in such applications. That's the results. Still on the same topic. We have just published a year ago with Professor Dombey and Janusz Tomasz a new article about the law importation for the preference implications. So we have showed also that such a formula, which is also investigated by many authors, and it is also one of the classical law in the classical logic, and it can be generalized to the functional equations case. So as I have told you, it has been studied for the R implications, S implication, Jaeger implications, and so on. Why it is important? Again, because it is useful in the practice. Martin had a talk about the similarity-based reasoning 2 days ago, but Bladel also worked on the hierarchical compositional rule of inference, and he showed that if we have some assumptions in connection with the law of importation, then again we have the the computational complexity can be smaller, and it can be useful in the applications. And also in 2023, this topic has been investigated not only for the norms, but has been investigated by for the aggregation operators. So as you can see here in this article, the author studied the Lovi rotation not for the norms, but using aggregation functions here. And we have done this similar. So we have gone to this topic using this paper. So we have thinking, okay, what will we obtain if we will put here the preference implication? And in this case, the theorem is the following. This is theorem from our paper that the only solution is just the preference, we can say the preference uninorm. So uninorm from the Pliant system. So the preference, which is used to generate the implication. So everything is connected with the same family of the functions generated by the one generator, and everything depends on the threshold here in this case. It is still an open problem where other fuzzy implications satisfy the law of importation with this aggregative operator. So as you can see in the case of the functional equations, depending on the assumptions, we can obtain the if and only if theorems or only theorem in one side. Okay. In a similar way, we have discussed a new family here, so-called mean implications. Because even here during many talks, it was some question or discussion wherever we need the associativity for the conjunctions. And here we have discussed the bisymmetric operations. What is really nice and important, and this is very old result from the 1966 presented by Atzel. In fact, this is some kind of some conclusions from his theorems, but we have a similar representation for the symmetric operations like for the associativity. We are all working with the T-norms. We know the characterization of theorems for the Archimedean T-norms, and we know the characterization for the continuous T-norms. But in the case of the symmetric functions, the characterization is very similar, but we have also some weights, and of course, the sum of the weights should be 1. So very similar, but not the same. And what is really interesting, the same characterizations we'll obtain for the autodistributive equation. So as you can see, these two theorems, this proposition and this theorem, in fact, the conclusion is the same, but the assumptions are different, and they can be obtained as conclusions from the original results from other books from the 1966 about the functional equations. Why he has not considered this in his book? Because as you can see here, we have the infinity. He considered only open intervals, okay, not closed intervals. So we needed to adopt his results to our case when we have also the infinity, okay. Using this one, we have the formula for the so-called mean implication. And for example, it can be in the following way. So we have just a nice formula, continuous one. And it also satisfies distributivity equations, not all of them, but we can show that it satisfies the two functional equations. So it satisfies D2 and D4. Doesn't matter, it's not important which one they are, but this family does not satisfy all 4 distributivity equations, but only 2 of them, okay? But again, we have the if and only if, here the theorem. Okay, and now the next topic, connected with this family, not only with these new families, but generally speaking with the problem of the approximate reasoning. In the classical two-valued logic, we all know that the modus ponens is the following. So we know that if P is true and the implication P implies Q is true, then Q is also true. Sorry. We know this. We also know that in the case of the fuzzy logic, it can be generalized to the generalized modus ponens. it is used in the fuzzy control. Of course, here is only one rule, but we can consider many different rules, and we can consider many inputs, maybe some also outputs. Like here in this example, in this article, they have considered multi-input single output, yes, system. But we know that this conclusion we want to obtain, so we know that we have some implication, we have some rule, we have some input. This input is maybe close to the A, and we want to obtain the conclusion. So as I have told, and Martin during his presentation, we have, for example, similarity-based reasoning, where we have some matching functions, we have some formula for this one, and in this case we are using the implication here. We have also the compositional rule of inference, and in this case, in the classical case, we have here the t-norm, here the implication. Of course, we can also use this implication. The minimum, this was also, I have heard here during this FSTA conference, some talks where we have such kind of the compositional rule of inference. And this topic was investigated many years ago by different kind of the authors, wherever we can obtain the modus ponens. And as you can see, mainly the group from Spain, they are working on the as an implication classical formulas of the implications. And also, I would like to mention that Kasia Miś, my PhD student, his PhD thesis was about the generalized schemas and rules of inference in fuzzy logic. So she investigated not only this one modus ponens, but also modus tollens and hypothetical syllogism, and also other constructions. Okay, so this topic was, we can say, well investigated, but we have decided to discuss this topic from the other point of view. So we are asking the following questions. Assume that x and x implies y are partially true. So we know that we have some values, and we want to know what is the true value of y. We assume that it can be, these true values can be functions of the continuous true values. And so we have introduced, in fact, Professor Dombi with Janusz Tomasz firstly, they have introduced the threshold realization of the modus ponens syllogism. And what they have obtained? Still, we are working with the preference implications. So in their article published a year ago in Fuzzy and Systems, they have obtained the following result, that if, okay, we have that f the set of all functions, it doesn't important, this is the generators of t-norms or t-conors, but they have obtained the following result, that if x is greater than some threshold, and implication is greater than such a threshold. I'm using the formula from their paper about the implication, so they are using more algebraical representation, because for them it is much easier to work on the algebraic point of view. I prefer the functional writing, but I'm using their way of presenting the proofs. And then y is greater than aggregate, than this uninorm, which we have seen also for the law of the importation. So everything is connected with this, again, with the uninorm generated from this aggregation. And generally speaking, they have introduced the preference, the so-called approximate reasoning based on the preference implication. So they have obtained such a formula. Just a very new article. It is submitted to the journal, International Journal of Approximate Reasoning, month ago. It is still under review. We have done the same way of thinking, but for the mean implications. We have obtained similar but not the same results. But the most maybe important, I'm looking for the maybe the most important is that it is interesting that if we take the other families like classical S implication or the R implication, it doesn't work. Will not obtain this theorem. Okay, but in this case we have this one, and we have also obtained this maybe this one. This definition is very important. So we have obtained the formula how we can obtain the result for the y. So we need to use such a function using generator. So everything is based on the generator and on the threshold. Some particular example. If you have some sentences, and we know what are the values of the sentences, assume the temperature high is 0.9 and this value of this implication is 0.7, then using our machinery, we can say, we can conclude that if we take particular functions, for example, for the product norm or for the dominant norm, and if we take particular threshold, which is just half, the standard one, then we obtain some numbers. Okay, I know that this is just the numbers, but this is like in the neural networks. We also obtain numbers. We also obtain some you can say some thresholds, should have some decisions. So interpretation, it should be chosen by the given conclusion, by the given application. So conclusion for this section. So I wanted to show you the preference implication. I have shown you that it was investigated in several articles from the different points of view. And also we have introduced the mean implications, and we have just introduced and investigated the threshold-based way of modus ponens, we can say. Okay, maybe I will skip this one. I had this part during my talk in the Košice about the scenes of equation. So maybe I will only just stress that we are also working on such a functional equation because it is interesting from the point of view of the applications and for the characterizations of the so-called p-power based implications. And it was investigated again by the Spanish group, by Sebastian group and Juan Torres. And we have obtained such nice results here, but maybe I will skip this one. And I will just only show you, during Bernard talk, Bernard also said one of the topic which is very quite popular here and well investigated is the migrativity. Just look for this, so we can obtain so many different kind of the functional equations. If we just only consider associativity equation with 4 functions, depending what we take, we obtain a different kind of the equations. If all functions are equal, we have just the associativity. But if the F1 and F3 is the norm and F2, F4 is a productive norm, we obtain the migrativity equation. The standard one introduced more or less 20 years ago, yes. If we take some other norms, we obtain the generalized migrativity equation for T norms. If we put here T norms and T norms, nice closed migrativity equation. But if we take implication and T norm, we obtain the law of importation. So as you can see, from one formula, depending on the situation, we can obtain different kind of the functional equations. And the question is why we want to investigate them. Of course, from the purely mathematical point of view, because we are looking for the truth, because we want to find the solutions. I know that Irina asked the question and during the presentation that we need to also look for the implications, why it is important, why it is interesting. So, okay, we can just think why, for example, migrativity is important in the practice. Okay. So we have just in this article with Balo and Radko, so 5 years ago, we have introduced the migrativity for fuzzy implications. And this topic was also investigated for last years for many authors. I will not put here my results because my time is going on, and I would like to go to the last part. But I only just want to stress that we have just introduced this law of importation for fuzzy implications, and now we have again a new topic connected with this equation. Okay. So the last part, fuzzy connectivity in machine learning. In my opinion, this is very interesting and important. And I would like just only to concentrate on on maybe two or three topics. First of all, I have started also with my friend, with Marek Reformat from the University of Alberta in Canada, about the investigations, how we can connect the large language models, retrieval augmented generation, so RAG models, with the fuzzy logic. So we extend classical graph RAG, introducing fuzzy knowledge graph, and we are using some triples, and we are using the confidence scores. And this weighted form a hierarchical fuzzy sets. So we have also a fuzzy sets representing conceptual summaries at the different document levels. So we have a full document and we have a section, subsection. We have three kind of the levels for the documents. And then we are using the fuzzy aggregations and multivariate logical implications, so fuzzy implications, to obtain the similarity scores that captures both relevance and confidence. So our goal is the following, that maybe goal is to obtain more explainable responsive generations language learn models based on the graph RAGs. And this is still under we are still working on this topic. So we have only presented this during the conference, IFSA conference, a year ago in Banff in Canada. And now we are thinking about the full article. But I want to stress here a very interesting article, and I want to thank you here to Vladik Krajinovic, because we all obtained many emails from Vladik about the different conferences and so on. But sometimes he also sent some interesting papers. And maybe you don't remember, but I remember that 2 years ago, 2 years ago, I think so, he submitted to the ELSTAT members the following article. This is a very interesting article. I'm still working with my master degree student about this article. I have still not checked all the results here in this article, but I wanted to show you that they consider the differentiable fuzzy logic operators. So they are looking from the different point of view. They are looking for not for the logical properties, but they are looking by we can physicians properties. Yes, you can think, but more connected with the gradient propagation. So that's really a nice. They have just considered really classical norms, classical implications. If you look to this article, they have really classical sets of logical connections. And in my opinion, this is quite interesting view how we can connect. We can say what we are doing in fuzzy logic with the machine learning society, and how we can connect our investigations with them. This is one example. In my opinion, very interesting, and I really want to go in this direction. And finally, also my previous PhD student of Salvin, he's working on the some theoretic of the fuzzy sets, but he found also a very nice article, 62 pages long, really pure mathematical article about the investigations and fuzzy symmetrical cells and their application to geometric data analysis. Again, we have a connection of the fuzzy sets, fuzzy logic, with some applications to data analysis. Quite interesting, connected with the category theory also, from the mathematical point of view, can be also investigated from the theory of category. But it was done by the German, as you can see here. I don't know the names, but they are working the Planck Institute. So also the quite interesting topic. I have not discussed many topics today, because we still have the interval evaluate fuzzy logic. I have also worked with Kasia Kaczmarek-Mayer on the similarity, not similarity, on the fuzzy linguistic summaries. Okay, yes, fuzzy linguistic summaries. So also we are working on this topic, and we are looking for some applications of this one. But I think that really this article is really, in my opinion, quite interesting, and I hope that this way of working with Marek will be helpful, and we will obtain also interesting results. So that's all. Thank you very much.
summaries of your work in last years, and there is a quite long time for discussion and questions.
Yes, thank you very much. It was really a really nice talk and the overview on also the rest of the topics. I wanted to ask you something about the paper that you also like. We also like the paper on differentiable fuzzy logic.
Okay.
Because I think that you said that you're not interested from the logical perspective. Okay.
Maybe they thought that maybe not interesting, but maybe some properties
Yeah.
which are interested for them. How to say, they are not connected. So from the logical point of view, some connectivities are interesting, but from the point of view of what they are doing from the point of view of differentiable fuzzy logic, I'm not a specialist on the fuzzy logic from the pure mathematical point of view, but I know that they are looking for the differentiable fuzzy logic. Yes.
I know.
Yes.
And but my question is, well, the thing is, if you need some logic behind the operations that they want to define, and you need differentiability, it is almost hopeless from my perspective, because once you put minimum and maximum, you break differentiability, right? Anyway, Lukasiewicz logic approximates every differentiable function. So in Lukasiewicz logic, functions are continuous, all of them, not differentiable, but they approximate up to every epsilon, every differentiable function. And I wanted to point you out, maybe I will send you a paper by Sandro Preto, one of my co-authors, and Marcelo Finger. They try to describe properties of neural networks by property of Lukasiewicz logic. But they can make this embedding, and it's a really recent paper, and I think you will find it interesting. We will send you the paper.
Thank you very much. Thank you. Thank you very much.
Next questions, remarks.
Thank you very much for your talk. In your slide somewhere, you explained that for importation, we can consider, instead of T-norm, aggregations. Am I right? So do you think that we can drop some other properties?
That we obtain the...
I mean, first we use T-norms, we dropped some properties and use aggregations. So do you think that we can drop more?
Yes, I think so that we can. Yeah, this is the question. Of course, maybe everything depends on the applications, because as you can see here, they are using some hierarchical inference. So they are using some particular algorithm for the control system, for the multi-input single output system, and they are using the aggregation functions. And of course, the question is, can we use here the other not necessary aggregation functions, but maybe some other class of functions? And of course, losing some properties, maybe we have a branch family of a new properties, but yes, maybe we can investigate. Yes.
So it's not a field that somebody. Okay. Because to me, it seems that we can develop some properties from aggregation and consider more general operations, or for example, change some properties with some weaker ones. Because aggregations totally have somehow strong properties. Also, it may happen for other part of your slides. Several places you use T-norms. So
yeah. So this is what I'm thinking, that of course we are using quite strict or small family, or we have a strict assumptions. And this is what we can see from the point of view of norms. That at the beginning of the T-norms 26 years ago, everything was done on the unit interval. Now we are working on lattices, yes, different kind of the structures. And from the mathematical point of view, this is a progress. And also here we can have a progress. Of course, I think that using in the practice we'll be working on the numbers, of course, yes, not on the making some abstract structures, but maybe from the point of view when we have many data and huge big data, then maybe we need to use some theoretical aspects to embed to the smaller one. No, yes.
Okay, thank you.
Thank you very much. Thank you.
You have just answered my question. What is the future of implication functions from the mathematical point of view or from the practical applications? Where you can see fuzzy implications in 10 years.
That's I don't know. I don't know, really. You know, it's a future, 10 years. I think that if you will ask here during FSTA 2016, wherever we will have the ChatGPT or something like that, we will know, we don't know. And we are in a different world now after this, all the changes. So 10 years currently, I think that we will still be working on some, yeah, maybe connections with the large models, maybe something like that. So some connection between the, we can say, probabilistic and classical cases like we have heard today. So there's some connection because we still are, we are still using the classical operations in the classical logic, classical conjunction, classical implication, and so on. So we need to use implication. Okay, thank you.
No further questions or remarks? If not, thanks the speaker again.
Thank you very much.
Thanks the audience that survived the night. Yeah, and before the closing ceremony, there is a one small announcement. So I will introduce Kasia here.
Okay, thank you very much. I promise I will be quick. So we all know how important it is in our career to meet proper people and also to get inspired at the early career stage. And as a fuzzy community, we have been doing ELSLAT summer schools. And this year there will be also next 7th edition of such school. So who can guess what we can see on the picture? Okay, glass, yes, but in which city do you know this building? You know, so can you? I know. Can you?
He's working with me.
I know. So now, can you guess? Give me the name of the city. Yes, Warsaw. Very good. So yes, indeed, Professor Grzegorzewski, please join me. And the next edition of the ELSLAT Summer School will be indeed carried in Warsaw with Przemek as a main organizer. We will do that in July. So please mark the calendars. And okay, Przemek.
Yeah, just this moment, the only we truly know is this 5 days, 6 to 10, and location. Yeah, all other information will be sent to you either directly to persons whom we know and through UseFlat website probably. Of course, if you are interested in, do not hesitate to mail me. Who is invited? Everybody who feels to be young enough. Yeah.
Yes, exactly.
It's devoted especially to PhD students and students in general, but we are not PhD students. I will be there. Yeah, probably. So, and how does it work if if there is somebody who doesn't know? This is a series of presentations which try to sketch the situation in a roughly perceived fuzzy set theory and surroundings. Yeah. I cannot promise this moment who will be the speaker, but my idea is not to ask too many speakers, but rather a few, and go more deep into the topic. Yeah, and of course, as usual, Warsaw is a nice city, and besides hard work, it will be hard work, we promise some social life.
Yeah, exactly.
Knowing me, you may expect that there will be some.
Yes, exactly. And also we will have like a doctoral program, like mentoring by UseFlat. So we will try to hear from students, also maybe somehow guide them, link them. So there will be, I hope, a lot of interesting activities for the students. So what you can see here, as Przemek said, this is the page where you can find information. Of course, we will be also mailing, but here all the details you can find under the Elspat Summer School. It's now just a brief, but we will keep updating that. And also you can always take a look at the conference section, because next year, of course, we will have a very important meeting again of our Elspat conference. Probably you know in which city we will meet next year for Elspat.
Bari.
Bari.
No,
We will go to the warm, exciting Apulia for Bari. The university there will organize the Elspat. Next year it will be 2027. And Elspat Summer School is this year already, this July. Okay.
So once more, you are invited. Do not forget about us, and we'll wait for you in July.
Yes.
Thank you.
So it's nearly over. We are approaching the closing ceremony. I know you are hungry. It's always difficult for me and emotional to close the conference. And what helps me is that I can lean on the shoulders of the photo database that is created during the conference, because this turns the focus of yourself from my personality to the pictures of your own. So I will show you just a few pictures and then say a few words about it. You may recognize yourself. I don't know if Irina is here right now. Some other pictures. I'll not be commenting that much. Zuzka also left. Mishka. Very serious scientific discussions. You know that Vice President. If you think about it, what you have just seen, what is the intersecting point of all these pictures? This is it. Thank you for your smiles, because they are the water that powers our organization's mill. As long as we see that faces on the pictures and also in 3D reality looking at you, we still have the power, and we want to go on, and we want to improve. We want to grow the conference into the future more and more. So thank you very much. This is really important, and this gives us a very, very strong message. So thanks a lot. But I should be also truly thankful to the whole FSTA team. It's not about me, by far not about me. And you know the team. You have been visiting them or meeting them, seeing them all the days here. General chairs, honorary chairs, organizing chairs, co-organizing institution representatives, program chairs. Yeah, honorary chair, Radko, founder of the conference. But let's not forget about the others who are not visible here. For example, Umberto, as one of the chairs, who helped us a lot when we were actually preparing everything from long distance before the conference actually took place or was held. And when I mentioned the others, I mean many more. The others, not only those that are visible, but those that are a little bit less visible, or even, for example, not visible, not mentioned on the websites, but they're essential. We need them. And this is a very actually symbolic picture. You can see just one person that will be exhibiting here in front of you, and three others that have to be behind the scene, because otherwise I wouldn't be able to exhibit. And this is really, actually really symbolic, because that's how the whole conference works. And there are many others that we should thank too. They are working days and nights. They are working before we start. They are working when we go to sleep. They're preparing everything, and they dealing with all the abstracts for months and months before actually the event became real. the registration team. I'm really truly thankful to all of them. There are also people who are actually behind the corner when you are giving a lecture. You don't see them, but you wouldn't be able to give the lecture without them. So I'm again thankful to all of you, and I appreciate it. Even when you are working that much, you are still keeping your smile, guys. And there are people who you wouldn't expect, but they are also participating, and there are many of them. I don't have pictures of all of them, but I'm really thankful that anyone can give hand to the organizer team. And there are sometimes even those that are that much invisible that they don't even appear on photos, but they are still here. But we managed to take a picture of them. This is Misha. He was excellently giving us really his time all the time. Let's observe the changes we make together. You participants, we organizers. We as organizers, we can only help the changes, but you perform them. This is how FSTA looks before we start, before you come. The things seem sad, empty, and without any soul. And we thank you for giving them their sense and lives. It's you who change it from that preparation organization work to something that is that beautiful and that gives us the spirit and gives us the belief that it makes sense to go on and to continue. Thank you very much, and I would like to. I'm looking forward to meet you all in 2028. Thank you.